Welcome.
Yeah. Hello, everybody, ladies and gentlemen. Thank you for the introduction, Mr. Chairman. And I would like to present some current knowledge about past and future climate changes in the Gulf of Finland region. I'm from the Leibniz Institute of Baltic Sea Research, so from the southern Baltic Sea, but I'm also located at the SMHI, the Swedish Meteorological and Hydrological Institute in Sweden. And I'm very thankful for the invitation to the organizers. Thank you. And I hope that you can see now my slides. Good. So, my motivation to go into this current knowledge about past and future climate is that you find in the literature and in the public perception many statements that we may doubt that they are true. For instance, the Baltic Sea salinity will decrease in the future. There will be less saltwater inflows into the Baltic Sea. Storms will be more frequent and extreme sea level events. There will be decrease in hypoxia. So hypoxia, the depletion in oxygen for the Baltic Sea, we heard already it's record high today. And it will not decrease due to climate change. And there are more cyanobacteria blooms in the future. So my question is this supported by current knowledge? And I would like to convince you in my talk, no, it's not. So what is it about? Within the science network Baltic Earth, an independent network addressing the Earth system science in the Baltic Sea region, regional climate assessments have been done since decades. So some regional IPCC reports, one can call it, the Baltic Earth assessment reports or Baltic's assessment reports on climate change, that was the previous name. There was a book published about the status of our knowledge in 2008. Another one, an update 7 years later in 2015. And then presently we are working with the third update of our knowledge. It's called BEAR, the Baltic Earth Assessment of Climate Change for the Baltic Sea Basin. The format has changed, so it's not a book anymore. It will be a special issue in a scientific journal, Earth System Dynamics. And all these activities from the scientists have been in collaboration with HELCOM. And HELCOM in previous years published from the material of the scientific oriented books, own reports. Now it's actually different. We work together with HELCOM to produce a climate change fact sheet, and this has been published in September this year. And you can download it from the HELCOM homepage if you are interested. So there's an ongoing collaboration between stakeholders and scientists, and I think that's very good to inform the public about the current knowledge. The article that I want today focus on is this one. It is under review. Climate change in the Baltic Sea region, a summary. And it's the knowledge gain since 2013, so since the last one. Based upon peer-reviewed papers, there are 33 parameters of the Earth system that has been addressed. Actually, it addresses all the parts, not only the water in the Baltic Sea region, but also the atmosphere, the land, the cryosphere, and so on, but not the anthroposphere. That was a decision by purpose that we said we focus on the physical, chemical, and biological parameters. So it addressed past, present, and future climate changes. Past means paleoclimate development, like presented by Daria before. Present changes means the changes during the instrumental period, and future changes from projections. 47 scientists participated. It's now 205 pages with a lot of figures and tables and more than 800 references. And if you are interested, you can join this process. It is on the internet, and you can see the submitted version already and the comments that we got so far. This is the summary that I will discuss in more detail during this talk. The 33 parameters are shown here. The drivers are, of course, the atmospheric CO2, the red boxes, and the aerosols that affect the radiation budget and the temperature in the region. And then we have the different compartments of the Earth system in light orange or brownish, light brownish color, the atmospheric parameters, in grayish, the cryospheric parameters, in blue, the ocean parameters, in dark green, the biosphere on land, and light green, the biosphere in the sea. And the dark brown is actually land parameters, physical land parameters. And all they are affected. And I will go and explain this overhead more in detail later. I should say, if you talk about current knowledge, it's very important to address confidence levels. And here in this assessment, we followed basically the IPCC philosophy, that we have 3 levels of confidence, low confidence, medium, and high. And this is according to agreement, consensus in the literature. So simply speaking, it's about the number of publications that stress a certain finding, or the evidence, type, amount, quality, consistency. So for instance, if you detect the trend in your data and this is statistically significant, you will increase the confidence if you have also an explanation, for instance, by models, if you can not only detect, but also attribute the change to climate change. And here, again, it's very important to stress there are many different factors influencing the Earth system, but the paper only focus on the climate change. And these are the pluses and minuses. So look, for instance, in the upper part of this transparency, air temperature, you have pluses in black. These are the past changes, and 3 pluses means high confidence. So plus, that is, of course, an increase in air temperature with high confidence. And the projection is the same. The increase is with high confidence. If you have other bubbles here in this diagram without any sign, then it's simply that we do not know. Okay, I will come back to the arrows later. Let's talk about present climate change. Because of the previous talk, I have not focused here on the paleoclimate changes. I skipped that, so I will focus on the instrumental period. These are data from land-based station over the whole Baltic Sea region. It's actually in blue, the curve show the Baltic Sea basin in the north, and then red in the south. And the division has been done at 60° north. And you see the different seasons and the annual mean. And it is very obvious that there is an increase. You see it just by eye without applying any statistical methods in wintertime and in spring. And this increase is larger than the global average. It's slightly larger than estimated in the earlier back reports. So we can say there is an acceleration in the trends. And so it's getting warmer and warmer. So the last back report, to remind you, was more than 7 years ago. So data from 2013. now we have an increasing warming. And this affects the cryosphere especially. Here you see the sea ice extend, the ice coverage over the whole basin. And this starts by reconstructions already in 1720 and has been continued until today. If you focus on the 2 time slots at the beginning of the last century and the present period, you see there's a shift in the distribution. So there occur no very severe ice winters anymore. That was the case before. So there was a bimodal distribution function for the occurrence of ice winters. Now it's actually more shifted to milder winters. And there's a trend, a significant trend during the past decades. If you look at river discharge, another very important parameter for the salinity in the Baltic Sea. This is actually not the entire Baltic Sea, but the slide shows the data from Sweden, because here the latest updates have been done. But if you look at the curve for the entire basin, it's actually pretty much the same. So you see here no trend. There are wetter decades and drier decades, but there's no significant trend in that. So, and also the high flow events, so extremes in this over the past 100 years are not statistically significant. But if we look more into the basin structure, if we look into the north, and this is this slide about, it's from Sweden and divided into the different parts of Sweden from north to south. And if you look at the region number 1, the bottom bay contribution of Sweden in the freshwater discharge, you see a clear trend here. So in the north, it has been wetter, but you can't see it for the salinity in the Baltic Sea. These are data collected for the entire Baltic Sea, sea surface data, starting with 1920. There are actually some older data available, but we have excluded it in this article because it is then difficult to construct annual means. And you see clearly there's a pronounced multi-decadal variability with some imagination. You can see here a 30-year periodicity, but there's no trend in this. There is a trend since the 80s, yes, but no trend compared to the very historic earlier time data. But if we look then at not only the mean for the year and for the entire basin, but for the gradient, and this is the slide, the panel to the lower left. This is the gradient between the north and the south, so the gradient in sea surface salinity. You see statistically very weak, but there is a trend. And now I come back to the confidence levels. So there might be something that there is an upward trend in the gradient. That means the north is getting fresher compared to the south. Modeling has been used, and with models you can manipulate it. So you can manipulate the freshwater supply. And this has been done in the 2 right panels. So there are curves, the reference model. That is actually also the red curve here in the left, but you see now to the right the sensitivity experiments. And if you focus on the blue one compared to the red one curve, then you see the red one is showing an increase in the gradient like the observation. But if you switch off the changes in runoff, so simply keep every year the same in runoff, there is a slight decreasing or no trend, no statistically significant trend in the record. So this is some evidence that this might be connected to the increase in freshwater supply in the north. Saltwater inflows is a very special topic. It has been also studied since decades. The famous record by Matthäus and Frank started in 1886, I think. That's the blue one. So the blue bars show the reconstruction, the earlier reconstruction of major Baltic inflows into the Baltic Sea in the unit gigaton. But then people wondered why there is a decrease in the frequency, and this was attributed to the increase in freshwater, so the climate change, as we have discussed before. But the green curve actually show now a new reconstruction by Moorholes, and it shows clearly that there is no trend. And what is the difference between the two records? Well, it's observational based, and in the first times, the observations are coming from a lightship, GZRF, in the entrance area of the Baltic Sea. And later on, it was the Marnet station at Darsil, and this station changed the location. So there were the lower record is not homogeneous, whereas the green record actually take that into account. So no trend in saltwater inflows. Sea level, as you all know, is increasing, and this is a rather robust signal, 24 centimeters for the period that you're shown here. It is also possible to see that there is an acceleration, but this you cannot reconstruct from individual stations. You need to have a look and to apply statistical methods carefully for all the different stations. Then you can actually see an acceleration. So about the future, these are the projections in air temperature. The upper rows show winter and summer, and it is according to different warming levels, different emissions of greenhouse gases. In the world, RCP 2.6 to RCP 8.5. This is still based on the previous IPCC report. So we have not done these exercises for the CMAP 6, so the latest report. But actually, I can tell you when you compare it, the numbers are pretty much the same if you would have applied a downscaling to our region based on the latest IPCC report. The average air temperature change over our region, so the Baltic Sea region, is 1.5 in the 2.6 RCP scenario that corresponds to the Paris Agreement. And the most pessimistic agreement that people nowadays believe cannot happen, even if we follow some fossil fuel path into the future, is 4.3. So marine heat waves has been studied. The increase in number and the duration, especially in the coastal zone of the Baltic Sea. And please have always a look also in the Gulf of Finland of these maps. So also there, especially the southern and eastern coasts are affected by marine heat waves according to these modeling results. I will not show you the sea ice, but it is clear that there is the projections will show a shrinking and thinning of the Baltic Sea ice cover. But there's still some ice in the projections in the very north in the mean. So very mild ice winters will still occur. So the Baltic Sea projections do not suggest any ice-free Baltic Sea in the future, even in the most pessimistic scenario. And here's precipitation. So the north is getting wetter in winter, and also the south. That's very clear and a robust result. But in summer, it is the north where the signal is clear. In the south, it's a transition region between the drying and wettening signal. So there it's unclear. But in the overall sum, river discharge is increasing, but the projections are widespread. So they are projected to increase between 2 and 22% in RCP 4.5 and 7 to 22% in RCP 8.5. But so as I said, a large uncertainty here in the amount of the increase. And I will give you some comparison because that has discussed quite a lot in the past, what happens with salinity during the different assessments. We have the first assessment report. There we found a large spread. You see it in the right table, from 0 to 3.7 gram per kilogram decrease. And nowadays, actually, the projection show no change. What is the reason? The very first projection increased ensemble members that have a large increase in the west wind that contributes to the blocking. So decrease and the blocking of the freshwater outflow. So increase in salinity also from the wind. The river discharge numbers have not changed so much in time in the projections. They have been all the time uncertain. But then a new factor has been considered, the sea level rise. And even if you take moderate numbers of 0.5 meter into account corresponding to the RCP 4.5 ensemble mean, you get then an almost compensation of the effect of river discharge because there are no significant changes in the latest projections in wind speed. So the sea level will continue to rise, but there's a high uncertainty. I'm speeding up a little bit, and I'm going also over the uncertainty. So I hope that I could convince you that it is not clear what is happening with Baltic Sea salinity in the future. There are counteracting factors. It's the wind, it's the runoff, and the sea level rise. And obviously the wind, the mean wind and also the extreme winds are not changing. So it's the interplay between the rising sea level and the increase in the freshwater. And we do not know the outcome, who is winning in this projection game. Saltwater inflows obviously have not shown any change in the past. So this less saltwater inflows was due to inhomogeneous time records, this conclusion. So that's not true. To the contrary, there has been some projections that suggest a slight increase in saltwater inflows. And together with the sea level rise, more salt is actually transported into the Baltic Sea, which each of the inflows. More frequent storms, no, that is not supported. And the same with extreme sea levels. Of course, the mean sea level is increasing and then the extremes are getting more extremes, but not due to an increase in the frequency of storms. Hypoxia, I have not talked about that. So the oxygen depletion, it's today record high. It will or will not decrease, we do not know, but this has nothing to do with climate change. There is obviously, and there's a new study around that shows that there is a substantial effect from the warming, from the past warming that contributed to the large-scale hypoxia in the Baltic Sea. But the dominant driver are the nutrient loads from land, so man-made actions in agriculture. And more cyanobacteria blooms, it depends as well very much from the nutrient loads and less from the warming, but it can be if the reductions are not as much as suggested by the Baltic Sea Action Plan, together with most pessimistic warming projections, there's an increase in cyanobacteria blooms.
Markus, could you please?
So my last slide. My last slide, that is the summary. You see here the errors, and I have not talked about that, but these are the dependency in the system affecting the difference. So what is really affecting by climate change, which parameter? And you see a lot of the black arrows. This is the heat cycle, and the air temperature is affecting the cryosphere. That's very clear. and also the water temperature is affecting some of the biological parameters. But the other errors, there are much less. The blue one is from the water cycle and from the momentum flux, so the wind import. There are some errors that affect it, but the knowledge, although it is thinkable, is quite low about any significant changes. So please have a look at the article, then these dependencies are discussed into more detail. This is just to give you a glimpse from the fact sheet, what kind of information you can get. You can zoom into the Gulf of Finland and you will get in easy language the information about the different parameters here shown by symbols. So the thermometer, for instance, is the water temperature. Some information for stakeholders, what we expect from the projections. And I thank you very much for your attention. I thank very much the contributors of all the scientists to the Baltic Earth Assessment Report. And I thank all the contributors to the climate change fact sheets. Also there, more than 100 persons contributed. Thank you very much.